Saxon Algebra 1, Lesson 90. We're going to do some more word problems. Last time we did what I called coin-ish problems because they all had the quantity and the value statements that we're used to seeing in those coin problems, you know, where you have the number of nickels, number of dimes, number of quarters. And last time we did problems that followed that same pattern of quantity and value. And one was about tourist / coach and first class tickets that were so cheap that it just made me want to jump on their airplane, Saxon Airlines. And then there was one about a dress shop, right, that only sold two prices of dresses. They were super cheap. It was fast fashion, right? Walmart dresses. I think they were $20 and $45 each. And they followed that pattern of quantity and value really closely. These problems are not really like that. These, I would only say, they're sort of quasi coin problems because they're kind of, but not really, excuse me, not really similar. They do not have quantity and value statements, okay? What they do have that's going to help us a lot is they have two statements of equality. Which means when we read them, we'll see John telling us in sentence form two things that are true. And we can take those and turn them into equations and solve them. The first one is about picking berries. I hope you guys, when you were little, read the book Blueberries for Sal. It was written by Robert McCloskey, who's the same guy who wrote Make Way for Ducklings. It's a great book, and it's my go-to berry picking story. Together, Charles and Nell picked 92 quarts of berries. Okay, so here's where I'm at right away. They're picking berries. We're measuring them in quarts. The number that Charles picked plus the number that Nellie picked equals 92, right? Let me read that to you again and see if that jumps out at you. Together, Charles and Nellie picked 92 quarts of berries. There it is, my first statement of equality. Now here comes the second statement. If Charles picked 6 more quarts than Nellie, how many did each of them pick? Okay, so I'm going to write this as an inequality first. Charles picked more than Nellie, who technically, I believe, the way this name is written, it's Nell. But I like to call her Nellie, because that seems more like of a berry-picking girl's name. Charles and Nellie. Can't you see it? Okay, Charles picked more than Nellie. 6 quarts more. So I'm going to add 6 to her side, and then that will make it equal. Okay? So if Charles picked 6 more quarts than Nell picked, how many quarts did each of them pick? Now we have two statements of equality. And as you can see, they did not follow the quantity value pattern. They're not really like coin problems in that respect, but they are like coin problems in that they create what we call a system of equations that we can solve with substitution or elimination, and we get to choose, okay? So you may do it any way you want, but this one is set up perfectly for substitution, isn't it? There's an NC, there's an NC. We're going to take that and plug it in right there. It's going to be joyful. Are you ready? We get that the number that Nell picked plus 6 plus the number that Nell picked equals 92. Okay, I can put parentheses around that. Sometimes that helps you just see how I substituted. That went in there. Okay. Now we're ready to solve, and this is this is the part where it's super coiny. Let's add like terms and subtract that 6 by swimming it at the same time. So we get 2 times the number of Nell equals 86. And then we find out that the number that Nell picked equals 43. Okay, that was easy-ish, right? That was pretty straightforward. It's kind of a big number, but it's okay because now to solve for the number that Charles picked. Our equation's beautiful. We just take the number that Nell picked and we add 6, so that would be 49. And we can double check. They have to add up to 92, right? And look, they do. So I feel pretty comfortable that's the right answer. And John agrees with me. Okay? Beautiful. The challenging thing about these problems is that we often have a lot of these statements where we say that one is greater and that there's a balancing number, or one is less than and there's a balancing number. So we have to be really careful with those, what I call balancing statements. And remember, the trick to these is to write an inequality first and then fix it. So I'm going to emphasize that part on our next one. There are quite a few of these. There are 6 of these problems. I hope you ate a good meal recently, because we could be here for a while. No, I'm just kidding. The number of boys in Sarah's class exceeded the number of girls by 7. Okay, so the number of boys is greater than the number of girls. It exceeded the number by 7. Okay, so we write it as an inequality first. The number of boys exceeded, that means is greater than. The balancing number is 7. I always like to bring balance to this side because it's easier than trying to squeeze in over here. I just do it, I don't want to say lazy, but to be efficient. Okay, so we see this is the bigger side, this is the smaller side. That's what that inequality tells us. The balancing number is 7, so I can see I need to add 7 to this side to make this one bigger because it was smaller to begin with. Now they're equal. And I just scrunch my equal sign right over the top. You have to do it this way or you'll get them wrong, I promise you. If there was a total of 29 pupils in the class, number of boys plus number of girls equals 29. How many were boys and how many were girls? So, system of equations. And again, we're set up perfectly to substitute. So I'm going to put this in here, and I'm going to say the number of girls plus 7 plus the number of girls equals 29, right? We substitute that in for here. I'll put parentheses on just to help you see it. We don't need them for the math's sake, but that just helps you see where I substituted. And then this is this part. Okay, I'm going to ignore the parentheses now because they're not doing anything but helping you understand what I'm doing. Subtract the 7, and then we'll add the like terms. 2NG equals 22. So the number of girls equals 11, right? And the number of boys equals the number of girls plus 7, so this must be 18. Should add up to 29. Yes, it does. Yay. 2 statements of equality. Let's do another one. The other thing I'm going to tell you is that when you're doing these problems in your homework, 90.8. Wow, I got really ambitious there, didn't I? It's 3. When you're doing these problems in the homework, if you're stumped and you can't figure it out, look through these 6 examples in the textbook, or you can look in your notes too, but they're right there in your book, which you'll be looking at because you're doing your homework. Find one that is written like your homework problem and then follow along if you need to. That is a great way to use the book to help you learn. And you guys have plenty of time. You're not getting ready to go to college next year, but I will just tell you this. In college, which I hope you both are planning to go to because you're really smart. It's just that simple. You're really smart. Professors don't always teach everything you need to know. You have to use the book to figure out some of the stuff. And so learning to use your book as a tool is a great idea. We'll work on that more as we go. Philip cut a 38-meter rope into 2 pieces. Okay, for this, I'm going to I'm going to keep reading. The long piece was 9 meters longer than the short piece. What were the two lengths? Okay, for this one, John suggests that we use letters. The long piece plus the short piece. They add up to 38, okay? Philip cut a 38-meter rope into 2 pieces. Okay, so the 2 pieces add up to 38. The long piece was longer than the short piece. Well, that kind of makes sense, doesn't it? The long piece was 9 meters longer. Okay, so we know we have to add to the short piece to make them equal. Okay? What if you didn't think of using long and short? What if I wrote it as the number of the first piece plus the number of the second piece equals 38? And then I said the number of the first piece equals the number of the second piece plus 9. What if I used more of a traditional pattern like that? Would that work too? Yeah, it's fine. You could use X and Y. The whole idea with choosing the variables is just to make it easy for yourself. So whatever seems easy to you is fine. Okay? But this is a great example of how it doesn't always have to be the little n's with the subscripts. You can do letters, and it's fine. All right, let's figure out this rope problem. Once again, we're set up perfectly to substitute. S plus 9. I'm putting it in parentheses just to show you. That's an S, not an 8. I got carried away. Equals 38, right? We combine like terms and we swim the number across and we get 2S equals 29. That's an S. It looks like a 5 to me. Okay? So we're going to divide both sides by 2, and we get S equals 14.5. That seems weird, but that's the right answer. Okay, so John doesn't always make it come out even. Every once in a while, he'll freak you out. The longer piece, we add 9, so that would be 23.5. Let's see, do they add up to 38? Yes, they do. So that looks good, and that's the right answer. Okay? Don't let John switching the variables freak you out, but if it makes sense, when we're saying one is larger, one is smaller, one is greater, one is smaller, go with whatever feels easy to you. 90.4. The sum of two numbers is 72. I'm going to do it like this. Number 1 plus number 2 equals 72. The difference of the numbers is 26. Okay. N1 minus N2 equals 26. Now, how do I know that N1 is the bigger and N2 is the smaller? I don't. But I can just set it up that way and it will sort itself out as I solve it. I could have put it the other way, N2, N1. It doesn't matter as long as we get the two correct answers. All right, now this, I see, this is all ready to eliminate, isn't it? If I add these, the N2s will cancel. So I'll get 2N1 equals 98. And then I'll divide by 2. And I'll get that the first number is 49. 98 divided by 2. All right, they have to add up to 72. So I can just do the math on that. Let's see, that would be 23. Let's make sure that works. I did it in my head. Right? If you needed to, you could work this out. If we have 49 and we know they have to add to 72, you just do 72 minus 49. I did that in my head. And then I tested it to make sure. So it worked out just fine to use N1 and N2. John didn't. He used the L and the S scenario again, but I wanted to do it differently just to show you that John's way isn't the only way. As long as it makes sense to you, it's fine. 90.5. the greater of two numbers is 16 greater than the smaller. Okay, I'm going to use G and S for this because that seems easier to me. The greater number is greater than the smaller number. All right, I can write an inequality, right? We always write the inequality first. I've been saying that, but I want to write it down. Then we balance it. This is so important, you guys, and John doesn't stress it enough in the book. I'm going to stress it until you want to cry. I mean, you know, and maybe we've already reached that point. Maybe right now you're throwing rotten fruit at your viewing screen. I don't know, but I'm just telling you, these are really hard unless you use this strategy. Greater is greater than smaller. I think so. The greater of two numbers is 16 greater. Okay, now we know to add 16 here, and that's equals. One of the things I don't like about the greater, like using the L and the S or the G and the S, is S's easily look like 5s, and that I don't like. Okay, when added together, their sum is 4 less than 3 times the smaller. Oh my gosh. All right, let's figure this out. When added together, their sum, okay, so G plus S, is less than 3 times the smaller. Okay, I left the number out, the balancing number, because I'm writing the inequality first. When added together, their sum is less than 3 times the smaller number, which we're calling S. Okay, so this side is bigger, this side is smaller. That means I'm going to have to subtract the balancing number, right? And the balancing number is 4. When added together, their sum is less than 3 times the smaller number. The balancing number is 4. This side is bigger. Originally, you can see it under there. So I subtract 4 to bring this one down. All right, hopefully that makes sense to you. I'm going to add, I'm going to decide, this is my system of equations. It's a crooked system, but a system nonetheless. And once again, we're all set up for substitution. So I'm going to say S plus 16. That's what went in for the G. Plus another S equals 3S minus 4. Okay. Let me add like terms here so I can see very clearly what we have. 2S plus 16 equals 3S, minus 4. Let's swim the S's this way, because then we'll have a positive number, and then that means we have to swim the numbers this way. This cancels, this cancels. 20 equals S. 3 minus 2 is 1. Okay, so the smaller number is 20. Yay. And we take the smaller number and we add 16, so the greater number equals 36. Is that right? Yay. One more. This one is one that always makes people crazy. Crazy, crazy, crazy. It seems weird, but there's a really simple thing to remember that'll make it easy. Example 90.6. The ratio of two numbers is 5 to 4. Okay, write this down and burn it into your brain. The ratio of 5 to 4, if we say it like that, is just a fraction of 5 over 4. So when we say something is the ratio of, we can just put it in a fraction form. Okay? The ratio of two numbers is 5 to 4. So the first number over the second number equals 5 to 4. That's an equation that we can use. Crazy, right? That seems so weird and hard, but it's super easy once you just remember this. When we say the ratio of 5 to 4, we simply mean a fraction. So when we say the ratio of two numbers is 5 to 4, and the sum of the numbers is 63, There it is, two statements of equality. Okay, remember this. I promise you, I'm 99% sure there's a homework problem that uses this language, and students every year, somebody's like, what in the world? I'm like, I know, it just means that. It doesn't seem logical, but it's true. Okay, so now we have to figure out how to solve this, right? What do we do with this kind of thing? We've never seen this in a system before. Cross multiply. So we get 4n1 equals 5n2. Now, that's fine, but that doesn't look very much like this, does it? John doesn't even show how to solve it. Huh, that's really interesting. What I want to do is say, let's substitute. These two look so different. I don't want to try and eliminate them. So let's rearrange this. n1 equals 63 minus n2, right? We just kick him over. I'm going to gently squiggle that out. Now let's substitute this into this. So 4 times the quantity, 63 minus n2 equals 5 and 1. All right. And this will be, what's 4 times 63? Let's figure it out. 12. 252 minus 4 and 2 equals 5. Oh, this should be a 2. I just copied wrong here. Right? There's a 2. That should be a 2. That was a 2. No, that's the 2 that we're copying. Never mind. I just copied it wrong. Okay, then let's add this to both sides. 252 equals 9 and 2. So now we have to divide by 9. 252 divided by 9. Ready? 9 into 2. No va. That's Spanish for it doesn't go. 9 into 25. Okay, it's not 3 times. 3 times 9 is 27. So close. So it's got to be 2 times. 2 times 9 is 18. We subtract 7, bring down the 2. Oh, 9 into 72 goes 8 times. So what we get here is that n2 equals 28. And then we know they have to add up to 63. So if we take 63 and we subtract the 28, right? I'm just subtracting here. And 1 should equal 35. And when they add together, we get 63. Yay. So now I'll box it and then I'll check it. Now, the way John, n1 equals 35, n2 equals 28. Yay. Got it right. Okay, this one is by far the trickiest of the 6 problems we did, but you now have great examples to use to guide you through your homework. This lesson, I just want to show you this. We're not doing it. It's got a practice and it's got a problem set, but it's got this class project. What? No, we're not doing the class project. That's kooky. And you won't need it because we're not doing problem 6. Okay, so carry on, ignore the class project, enjoy lesson 90.